Last time, in the village, we drew one ribbon of best fit, one input, the size of a house, one output, its price. But life is rarely that simple. Welcome to the Guild Hall of Crafts. Look up hundreds of profile cards, swaying gently on linen lines. Each card is a person, years of experience, education, city, department, a skill score, and on every card, a small golden tag, the salary. Today we ask a bigger question. When many things matter at once, how does a model weigh them all? Take a breath. Let's find out, together. A salary doesn't come from one thing. Experience matters. So does skill, education, even the city you work in. In simple regression, we had one ribbon, one weight. Now, each feature gets its own ribbon, its own weight, and the model braids them together into a single prediction. That's all multiple linear regression is. The same gentle idea, just with more threads. If that feels abstract right now, that's alright. We're going to watch every thread, one at a time. Let's read this little equation together, slowly. On the left is salary, the thing we want to predict. On the right, W1 times experience. That's the first ribbon, experience, with its own weight. Then W2 times skill, a second ribbon, skill, carrying its own weight. Then W3 times education, and those little dots tell us more ribbons can join whenever we need them. And at the very end, plus B, the starting point every prediction begins from. One feature gave us one ribbon, many features give us many ribbons, and this equation is simply how they all braid together into a single number. Let's open the Guild's ledger. First, we invite Pandas to the table. Import Pandas as PD, our quiet librarian. Then, reacts. Watch the ledger unroll. 500 craftspeople, 7 columns each. Shake confirms it. 500 rows, 7 columns. And head brings the first 5 people forward. A salesperson from Austin, an engineer from Denver, a researcher with a PhD from Seattle. Notice something. Some columns hold numbers, but education, city, department, those are words. Hold on to that thought. It matters soon. Let's walk through these lines, one at a time. First, import Pandas as PD. We invite the Pandas library in, and give it the short, friendly name PD. Next, salaries equals pd.readcsv, with the file name employeesalary.csv. This opens the file and pours all of its rows into a variable called salaries. Then, print salaries.shape, and the answer comes back as 507. 500 people, 7 columns each. And finally, print salaries.head, which gently shows us just the first 5 rows, enough to meet the data, without being overwhelmed. Before we teach anything, we look. Slowly, info tells us what each column is made of, numbers, and 3 columns of words. There they are again, education, city, department. Pandas calls them object. We'll call them categories. Describe gives us the feel of the numbers. The average salary here is about 84,000. The lowest, 38. The highest, 158. And ISNL checks for gaps. 0 missing values. The ledger is complete. Take a moment here. A model is only as honest as the data it learns from. We just checked ours. 3 gentle lines, each one a different way of looking. First, print salaries.info. This tells us the type of every column. Experience and skill score are int64, whole numbers, while education, city, and department come back as object, words. Next, print salaries.describe. This summarizes the numbers for us. The mean salary, about 84,730. The minimum, 38,000. The maximum, 158,000. And last, print salaries.isnl.sum, which counts the empty cells in every column, and finds 0 missing values. 3 quiet looks, and now we truly know our data. Here's the gentle problem. A model can only do arithmetic, and you can't multiply the word Seattle by anything. So we visit the stamp station. PD Jetdamies takes each word column, and turns it into a row of small yes or no seals. This is called one-hot encoding. Watch. Master becomes education master. 1 education PhD. 0. 1 seal warm and golden. The rest resting quietly at 0. Notice drop first equals true. If someone isn't master and isn't PhD, they must be bachelor. We don't need a third seal to say so. The missing seal is understood. Our ledger grows from 7 columns to 11. All numbers now. All ready. If you prefer, scikit-learn has a tool called one-hot encoder that does this inside a pipeline. Same stamps, different desk. The first line categorical calls is a small list holding 3 column names, education, city, and department. Then the main step salaries encoded equals pd.getDummies. We hand it the salaries data. Tell it which columns to convert. With columns equals categorical calls. Set drop first to true. So one redundant column per category is quietly left out. And type equals int. So the seals become clean ones and zeros. Next, print salaries encoded .shade. 500 rows and 11 columns now. And finally, printing the columns as a list reveals the new names. Education Master, Education PhD City Denver, City Seattle, and the 3 department columns. Every word, now a number. Now we set the table. X holds everything the model may look at. The features, 10 of them now. Y holds the answer we wanted to learn. The salary, into the golden envelope it goes. And then, the split. 80% of our craftspeople stay to teach the model. 20% step out to the courtyard, behind the gate, unseen. Later, they'll return. As a fair, honest exam the model never peaks. That's the rule of the gate. We begin by importing train test split from scikit-learn's model selection. Then, x equals salaries encoded .drop. Salary, axis 1. Everything except the answer, are 10 features. Next, y equals salaries encoded. Salary, just the answer column, all on its own. Now the split itself. Train test split takes x and y, with test size 0.2, meaning 20% is set aside for the exam, and random state 42. So the shuffle comes out the same every time we run it. 4 variables come back. X train, X test, Y train, and Y test. And the final print confirms it. 400 rows for training, 100 for testing. Now, the part I love most. Let's watch it learn. Slowly, with real numbers. To keep things gentle, we'll follow just 2 threads for now. Experience and skill, plus 1 starting point. B. Here's our craftsperson. 5 years of experience. Skill score, 80. True salary, 72,000. The model begins with a guess W1, 3,000 W2, 200 B, 20,000. So it predicts 3,000 times 5, 15,000, 200 times 80, 16,000, plus 20,000, 51,000, total. But the truth is 72. The error ribbon stretches out, 21,000 too low. So the model nudges. Just a little W1 rises, 3,000, to 3,400 W2, 200, to 260 B creeps up to 21,000. Let's try again. 17,000, plus 20,800, plus 21,000, 58,800. Look at the ribbon. Shorter now. 13,200. One more nudge, and the error shrinks to under 8,000. Notice, the model never leaps. It only nudges, again, and again thousands of times, across all 500 people at once, until W1 settles near 4,180, and W2, near 460. That's it. That's the whole secret. Guess, measure the error, nudge, repeat. If this felt fast, that's alright, we'll see this rhythm again in every episode. It only gets more familiar. Let's read the numbers on this chart. Gently. Our craftsperson has experience 5, skill 80, and a true salary of 72,000. In iteration 1, W1 is 3,000, W2 is 200, and B is 20,000. So 3,000 times 5, plus 200 times 80, plus 20,000, gives 51,000. The error, 72,000 minus 51,000, 21,000 too low. So each value is nudged. W1 to 3,400, W2 to 260, B to 21,000. Iteration 2 predicts 58,800 error, 13,200. Iteration 3, 64,050 error, 7,950. And after thousands of tiny nudges, W1 settles near 4,180, W2 near 460. Everything we just watched by hand, scikit-learn now does for us. 3 lines. We import linear regression. We create the model, an empty loom, threads loose, and then, fit, listen, all 400 cards, all 10 features, every nudge we saw, and thousands more happening in less than a second. In episode 2, one feature gave us a ribbon, a line, with many features. The model weaves a plane, a sheet of best fit, laid gently through the cloud of data. The loom is quiet now. The weights are chosen. Let's go read them. Just 3 quiet lines here. First, from sklearn.linear model, we import linear regression. The loom arrives on our workbench. Second model equals linear regression, with empty parentheses. This creates a fresh, untrained model. All its threads still loose. No weights chosen yet. And third model dot fit, with X train and Y train. This is the moment of learning. All 400 training rows flow in, and every nudge we just watched by hand happens here, thousands of times, in under a second. When the print says training complete, the weights have settled, and our model is ready. Here is the quiet beauty of linear models. You can read them. Each thread is a feature. Each tag is its weight. How much one unit of that feature moves the salary. Every extra year of experience. About $4,180. A PhD $11,500. On top of a bachelor's. Working in Seattle. About $5,200. And look at this one blue thread. Department sales. Negative. In this data, sales roles earn a little less than the baseline. The thread pulls gently downward. One more thing. Don't be fooled by thin threads. Skill score is only 460 per point, but a skill of 92 contributes over 42,000. Small weight, big numbers, large voice. Warm gold lifts the salary, cool blue lowers it, and B, 21,500, is where every prediction begins. The first line coefficients equals pd.series, built from model.cov, with index equals x.columns. This pairs every learned weight with its feature name. Then we print them, sorted from largest to smallest. Education PhD at the top, 11,650. City Seattle, 5,200. Education Master, 4,800. Experience, 4,180 per year. Down through skill score at 460 per point. Age at 290. And 1 negative. Department sales, at minus 1,850. Finally, we print model.intercept, rounded, 21,500. The quiet starting point of every prediction. Someone new has arrived. 8 years of experience. A master's degree. An engineer. In Seattle. Skill score. 92. 31 years old. We write her details as one small data frame. The same columns. In the same order. The model learned from. That reindex line is a kind habit. It fills any seal we forgot with 0. And then predict. Watch the threads do their arithmetic. Start at 21,500. Experience adds 33,000. Skill. 42,000. Age. City. Degree. Department. Each thread adds its share. $118,750. No mystery. No magic. Just every thread. Weighing in. And you can check every line of it yourself. We start by building new person. A Pandas data frame with just one row. Inside it experience 8. Age 31. Skill score 92. Then the seals. Education Master. 1. Education PhD. 0. City Denver. 0. City Seattle. 1. Department Engineering. 1. And Research and Sales both 0. Next comes the reindex line. New person dot reindex. With columns equals x dot columns. And fill value 0. This arranges every column in the exact order the model learned. Filling anything missing with 0. Then predicted salary equals model dot predict. New person. Taking the first result. At index 0. And the print shows our answer. $118,750. Now, the exam, the 100 cards the model has never seen come back through the gate. We predict a salary for each one, and measure the little threads between guess and truth. The mean absolute error. On average, we're off by about $4,300. For salaries near $85,000, that's a gentle miss. Our MSE is similar, but it listens harder to the big mistakes. 5,900, and R to the power of 2, 0.91. Our threads explain 91% of the salary story. The rest, life's quiet randomness. Look at the chart. Prediction on one side, truth on the other, and the dots hugging the diagonal. When guesses match reality, they gather along that line. Ours do. Take a moment. This is what a healthy model looks like. We import NumPy as NP, Matplotlib's pipelet as PLT, and 3 measures from sklearn metrics. Then, ypred equals model.predict on x test. 100 fresh guesses. Now the measuring may comes from mean absolute error. Comparing y test with ypred. $4,320 rooms is the square root. np.sqrt of the mean squared error. 5,880. And R2 from R2 score 0.91. Finally, the picture plt.scatter draws y test against ypred plt.plot adds the dashed diagonal from the minimum to the maximum. We label the axes actual salary and predicted salary, and plt.show reveals the chart. Our loom has done its work, so we put it away with care. Joblet dump wraps the trained model into a single file. Every weight, every thread preserved exactly as it settled. We save the column list too, a small kindness to our future selves. So new data always arrives in the right order. There it rests, on the shelf, beside the village compass from last time. Tomorrow, or next year, one line of code, joblet load, and the loom wakes, ready to weave again. No retraining needed, only a few lines, but they matter. First, import joblet, the library that wraps models for safekeeping. Then, joblet.dump, with 2 arguments, our trained model, and the file name salary prediction model.pkl. Every settled weight is written into that single file. The next line saves a second parcel, joblet.dump again, this time with x.columns as a list, into model columns.pkl, so future data can always arrive in the right order, and the print confirms it. Saved, salary prediction model.pkl. Later, whenever we need it, one line, joblet.load, wakes it all up again. This little loom is not just a lesson. HR teams use models like this to set fair, consistent salary bands. Job platforms use them for the estimated salary you see beside a listing. Analysts use them to compare pay across cities and roles. And one gentle note, a model learns the world as it is, not as it should be. If the data carries unfairness, the model will echo it. Good practitioners check for that. Always. A model is a helper for human judgment, never a replacement for it. Let's read this notice board slowly, line by line. The first card, HR teams, using models like ours to set fair, consistent salary bands, so similar work earns similar pay. The second, hiring platforms, that estimated salary you see beside a job listing. Behind it sits a model very much like this one, quietly weighing features. The third, compensation studies, analysts comparing pay across cities and roles, just like our City Seattle and City Denver threads. And the fourth, small businesses, planning next year's payroll with a trained model sitting beside the ledger. 4 small cards, one gentle idea, working quietly, everywhere. We've learned to braid many straight threads, but look through this door. In the glasshouse garden, a seedling is growing, and its story curves. A straight ruler cannot follow it. Next time, we teach our threads to bend. Rest here a moment. When you're ready, the next door is open. Today, you built something real. You turned words into numbers. You watched weights learn, nudge by nudge. You read a model's mind, thread by thread, and you shelved it, ready for tomorrow. Well done, truly. When you're ready, the garden is waiting.